Question number 14. The graph shows the variation of the internal energy U with temperature T for a sample of an ideal. When we given an ideal is given, gas is given, you are always being protected by the ideal gas equation. R is the gas constant. How many moles of the gas are in the sample? That's the question. Now, now how do we solve this one here? So we know that whenever you have number of moles, okay, then you can write U is equal to 3 by 2 nRT. This is what is the equation I can write here. If that is the case, you see U versus T should pass through a straight line, should pass through a origin. But see, it's an y-intercept over here. Why does it have? Because I always tell that whenever you are using thermal physics, T should be in Kelvin. Now you see it's in degree Celsius. That means if you put this in Kelvin, then it will be passing through the origin. So since it is in degree Celsius, this should be put as 300 over here. Now what I will do is I'll write U here, I'll write U here divided by 3 by 2 n into R. I can always use R here because it's an ideal gas. If it was not given as an ideal gas, you should not use this. Multiplied by 300. I get this value here. Now what do I get here? 2 ones are 2 150s are 3 into 150 becomes 450 over here. 450 enough. Okay. Now you need to get the value of U. Now U value here is going to be 4500. So what I will do is I'll write 4500 at T equal to 27. We already put T equal to 27, 300 over here is equal to 450 times NR. 450 ones are 450 tens are. So N should be equal to 10 by R. So 10 by R is there. Yes, it's there. Answer D.